Alright. Hey everybody, welcome to the stream. So in the last stream we reviewed this notebook up to this point. In this stream we are going to continue reviewing this notebook and we'll start with weight decay. If you don't know it already, this notebook is from the FastAI course. And this notebook contains the collaborative filtering application using deep learning. Hey man, what's up? I'm just reviewing the course material of FastAI. Weight decay. So last time when we implemented the collaborative filtering, we got up to this point. We got validation loss of 0.89. So this time we are going to review further techniques which will improve collaborative filtering. Weight decay or L2 regularization consists in adding to your loss function the sum of all weights squared. Why do that? Because when we compute, let's first read this paragraph. So last time, instead of being better, it ends up being worse. So we are talking about this validation loss. So it flattens out at 1 and 2 epochs, and that starts to get increase and get worse. So it got up to 0.89, which was worse than the first epoch, which was 0.86. Why is that? If we look at both trainings carefully, we can see the validation loss stopped improving in the middle on the first and second epochs and started to get worse. As we have seen, this is a clear indication of overfitting. In this case, there is no way to use data augmentation, so we will have to use regularization technique. So this weight decay is basically a regularization technique which will improve our model and so that it generalizes better on the validation set. Weight decay or L2 regularization consists in adding to your loss function. To your loss function, the sum of all weights squared. So here we were using mean squared error loss function. So this is that weight decay is basically adding to your loss function the sum of all the weights squared. Let's read on. Why do that? Because when we compute the gradients, it will add a contribution to them that will encourage the weights to be as small as possible. When we compute the gradients, it will add a contribution to them that will encourage. Okay, why would it prevent overfitting? The idea is that the larger the coefficients are, the sharper canyons we will have in a loss function. If we take the basic example of a parabola, so this is a graph of parabola. Okay, This is the equation of parabola. Y is equal to a x square. The larger a is, the more narrower the parabola. So for a is equal to 50, we have this kind of parabola which is narrower, and as the a decreases, the parabola starts to open up. For a is equal to 1, it basically is like this. So the idea is that the larger coefficient, okay, the sharper canyons, but that doesn't explain why it would prevent overfitting. Let's display the figure as well. So letting our model learn high parameters might cause it to fit all the data points in the training set with an over complex function that has very sharp changes, which will lead to overfitting. Okay, so letting our model learn high parameters might cause it to fit all the data points in the training set with an over complex function that has very sharp changes. Limiting our weights from growing too much is going to hinder the training of the model. Limiting our weights from growing too much, but it will yield a state where it generalizes better. Going back to the theory briefly, weight decay, or just WD, is a parameter that controls the sum of squares we add to our loss. Assuming parameters is the tensor of all parameters. So not only we have a loss, but additionally we add this term, which is basically the sum of all weights squared. Sum of all weights. This should be weights, parameter weights, weight squared, and sum, and we multiply it by a weight decay parameter, and we add it to the loss. But I still don't get that why in adding this term reduces overfitting. So suppose if we were to keep this loss as it is, then it gives this kind of behavior where it starts to flatten out and starts increasing, means it is overfitting. They are saying that here the idea is larger the coefficient. Now why are they talking about coefficients? So this is parabola, okay. Wait, does this parabola represents the loss function? And suppose if it represents the loss function, then why is this worse than having this kind of parabola? So letting a model learn high parameters might cause it to fit all data points in the training set. Which will lead to overfitting. Okay, I get this line that limiting our weights from growing too much. So if we limit our weights from growing too much, then it won't learn as much faster, I guess, right? That way it won't overfit that much drastically, I guess. Loss is another function as well. So we are adding this function to loss. Let me read it again. I think I should find out other material which might this thing called weighting. Okay, let's write this article because I'm not sure exactly how it works. The way data that was on the data side or whatever model side of things. Weight decay. Okay, I know about underfitting, just right, and overfitting. Origin of weight decay. First of all, real world data is not going to be simple. Okay. It is actually very limited, exactly. More parameters mean more interaction and more non-linearities. However, we don't want this interaction to go out of hand. Hence, what if we penalize complexity, we will still use a lot of parameters, but we will prevent. Okay, I think I'm getting it. This is how the idea of weight decay came up. We have seen weight decay in my article on, yeah, I'm also doing the same application. In fact, every learner in the FastAI library has a parameter. Okay. So he is talking in context of FastAI library as well. This thing called weight decay. One way to penalize complexity would be to add all parameters to our loss function. All our parameters. Well, though that won't quite work because some parameters are positive and some are negative. Okay, so we penalize the complexity by adding all parameters, but we can't do that because some are positive and some are negative, and that's why we take square of parameters. That's why we do the square of all parameters to all of function, sum of squared parameters. Now if we just add square of sum of square of all sum of square of all parameters, then the loss will get so huge that the best model would be able to set all the parameters to 0. So that's why we have this weight decay parameter as well, which only selects the fraction of this sum. So when we update weights using gradient descent, we do the following. second term with respect to dw would be weight into this will be squared, so 2x. That is, from now we would not only subtract the learning rate gradient from the weights but also this, not only subtract learning rate into gradient. So also this we are subtracting a constant times the weight from the original weight. This is we are subtracting a constant times the weight from the original weight. Okay, I get it now. And my parameters may cause it to put all the data. But wait, in this case they are adding this, and this guy said that okay, he's also adding it, I guess. Here it is adding it. Okay, and adding it, but at the end we are subtracting that thing from the weight, so adding some more thing will only make this weight less, so that's why it won't have this kind of sharper edges and it will generalize better. Okay, now I get it. So let's read on. In practice though, it would be very inefficient and maybe numerically unstable to compute that peak sum and add it to the loss. If you remember a little bit of high school math, you might recall that the derivative of p square with respect to p is 2p. So adding that big sum to our loss is exactly the same as doing so we don't add this squared sum, but we add first the gradient and directly add the gradient of this term to the gradient which we got after computing this loss term. So we don't need to take the square, because if we take the gradient of this term, it equates to, so x something, x square, parameter square is equal, is the gradient of parameter square is 2p, 2 parameter, like this, p square is equal to 2p. So this turns out to be 2 into parameter, and this remains at it as it is because it is a constant term, right? But we are still summing it, right? Hey Jan Pong Thong, how are you doing? In practice, since WD is a parameter that we choose, we can just make it twice as big. So we don't even need the two. Yeah, that's good. I'm great as well. Are you also a machine learning engineer, or are you learning machine learning or something? We don't even need the two. So yeah, I'm learning. Actually, I'm doing this course, FastAI. FastAI. I'm doing this course for FastAI, and in this stream we are reviewing the material from this course. All right, you are new to programming. So, what kind of programming are you doing? Web development. Oh, you are finding someone to help you. Cool. So, what kind of development are you into? Web development. Cool. So, what are you trying to learn? Front end web development or the back end part? Or you are more of a, full stack developer or something? Like, which part are you interested in most? Okay, the both part you mean. That's great. I have also done some web development previously. I used to work with full stack JavaScript. I used to use Vue on the front end and Node.js Express and mostly MongoDB on the back end. What about you? Have you picked any tech stack? Like, are you learning any particular language like Python or say JavaScript? Well, yeah, actually, mean stack is basically how you are learning Django. So mean stack is basically MongoDB, Express, Angular, and Node. So I didn't learn the Angular part of that stack. I learned Vue basically. Well, I'm also a noob actually. I'm not an experienced programmer. Python skill. So have you tried building any web applications? Like, are you doing any tutorials only, or you're also building projects of your own? That's good. Actually, that's how we learn. Test what? Test your skills? What do you mean test exactly? Yeah, sure. Provide me the links. I will check it out. Although, as I said, I'm not a experienced programmer or something. I'm just I'm also learning this stuff, and I have not worked with the Django framework. Sure, let me open the link. Self-learning software and web development research in the blog. So you are also interested in hardware learning. So you already have good set of projects. Why do you feel lost then? You are definitely improving your skills, as I can see from your projects. Why do you feel lost? Is it because you are, self-learning all this stuff and you feel alone or something? Refresh the memo. Oh, cool. Oh, damn. The voice is intense. Let me introduce it. So these are cool applications, man. Changes. What kind of bug? Do you mean that it doesn't start automatically when you first load the page? Is that the bug you are talking about? Okay, so that. Okay, you mean this bug. So it gets stuck and it doesn't get out, right? It is definitely an intense bug, man. It blows out my ears. So I guess there must be a logic flaw or something. Have you mm, have you designed it from scratch, or are you using any library? Ball bouncing like DVD. For this, I mean. Okay, it seems that you are using the canvas library. I'm not that much familiar with this library. Okay, let me try to read it. Field circle. Okay, so this code gets the ball basically, right? And you're getting, let me open up other file as well. Speed, radius, step, delta. If x plus radius is greater than width and x minus radius. So I guess this is basically when it hits this part, and this must be when it hits this part, right? And then try to play. What does this line of code do? Delta x is equal to minus delta x times time first. Changes the ball movement. Okay, so that must be causing the problem, right? Because changes the ball movement to negative. Okay, so opposite you mean, right? So if it hits the edge, then you are basically changing the direction. The logic is that it should bounce back, but instead of bouncing back, it gets stuck at the edges. So why does it get stuck at the edges? If start is equal to times 10, delta x is equal to speed. So if we pass negative speed, then it goes in that opposite direction, right? So it starts out at as 150. By the way, you said you feel lost. Why do you feel lost? You feel that way. Well, that must be a certain reason, right? Yeah, I mean, even I feel that kind of stuff. Like this morning only, I was feeling that, you know, why am I doing this fast AI course? But and I was feeling that I'm just doing this, courses and tutorial and stuff, but I'm not building stuff. So I guess the thing is to keep yourself motivating and keep building stuff. And I know it's hard because I'm also a self-taught guy. Well, that's the reason when I started streaming on Twitch and YouTube, because this streams keep me motivated and it gives me another kind of boost that keeps me progressing toward the courses I'm doing and the projects that I'm doing. And I guess you should also try to increase the level of the projects that you are doing. Maybe that will increase the motivation. No, I'm not that much good with it. In fact, I started using Python just like I have used it previously. Well, no, that's incorrect actually. You don't need to be that much good at Python to start doing AI stuff. In fact, you don't even need to be that much good with mathematics. And this fast AI course is structured that way that it doesn't start from the bottom up approach. It doesn't go into the details very much. Like it doesn't start from the mathematics background. It starts on the from the top. Check out blog. Okay, yeah. Oh, cool. So these are all the applications that you built. These are awesome, man. Even I don't have such cool projects. Tic-tac-toe in Python AI. So does this PyChem library provides this tic-tac-toe AI or something, or did you implement it, the algorithm yourself? If you want it on your system, there is clear instruction for running space invaders. Cool. So you have uploaded it as an apt-get project. Awesome. Get the Python 3 game. Alright, I will just install it on the local system. Direct it appears on the next second. Cool. Why does it start on the same block every time? I guess it is not that much intelligent AI. But this application looks cool, man. So what kind of algorithm are you using in this AI? So there's also a command line version. That's awesome. Let me try to open that one as well. Okay, so the command line version doesn't have any AI, I guess, right? AI. Cool. This version has 3, 4, 5. 1, 2, 3, 4. Hmm. So are you still learning, or have you gotten a job or something? Because it seems that you already have a nice portfolio that you can apply for a job. But no, man, it doesn't seem like you are a noob anyway, because you have good projects on your hand. Commerce site forbidding. What is this template engine called? Jinja or something? That's right. Okay, you don't have a job. Well, even I don't have a job, man. Why do you think I'm streaming stuff? That's why I'm streaming this stuff. No, 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 I'm not a pro at all. I'm just learning stuff. So the problem with me is that I try to learn something, and after some time, like 2 months or 3 months, I get bored and I leave it, and I get back to another thing. So that's why I don't have a good set of portfolio which I can show to anyone, which shows my skills. I'm like that, jack of all trades, master of none. Previously, before getting into AI stuff, I was into hacking and all that. I was doing bug bounty stuff, if you have heard about it. Bug bounty, I was doing that, but after some time, it got boring, so I left it as well. And that's the reason I have started streaming stuff, because I have so many different interests that it's very hard to catch up and integrate all of that. So that's why I'm just streaming stuff. Well, I have attended 2 years of computer science, so I did have, and we did have that subject C. I didn't learn C++, but I learned C at that time. So if I need to make something, I can get around, like I can Google stuff and get around building it. So I guess you are also learning C and C++, right? You have written it on your website, C and C++. So I want to get into Go language. So, in this stream, recently I'm also doing another project which is Nanto Tetris, which is basically making a Golang. Right now I'm also doing this another project which is building a modern computer from first principles using NAND. So I'm not building a hardware computer like from the logic gates, but I'm using a simulator provided by this course. So I also stream about this project. So once I'm done with this project, I will get into Golang programming. Yeah, sure. For actually, for why I don't have a job is because I have previously, in my previous job, I was working as a front end developer, and I got fed up with it, so I left it. And after that, I kind of lost interest in web development. Like totally, I was totally burnt out, and that's why I didn't get back to any other job. But and that's why I want to get back into Golang programming, because it is mostly focused on the backend part and very logical heavy stuff. So well, you can say that I got into college in 2015, computer science. So I have been learning programming since 2015, but it was on and off, on and off. Like I was not programming consistently, and I don't even have that many projects on my hand. I did build one website, begin bot can help you. Okay, so I guess he's another Twitch streamer, right? Begin bot. Well, there's also this guy named RWX Rob. He also streams in Go. He's very Go pro in a Go. Cool, I will check his channel. Okay, yeah, I come across his channel, but when I came across his stream, he was building a game bot or something, I guess, in Go, or maybe he was playing a game. I don't know. I don't know. Yes. So have you started learning C and C++? Mm. All right. So what other projects are you working on right now? Like right now, what exactly are you working on? Is it any website or any game or something? The commerce, okay, the web com. So I guess after you are done building that e-commerce website, you can definitely like easily get a job, right? Because this Django and Python is like very much sought after in the industry, more than Flask, I guess. Django framework is very much sought after. Yeah, definitely, it is bigger. Will 4 months good. So in fact that is good, because the bigger the projects, it will have an impact on your portfolio. You can show the masterpiece of your work finally. Style the site. Okay, and you are using the custom template, right? Well, yeah, during my web development I used to use this frameworks like Bootstrap and Bulma. but I mostly like this Bulma. It is very clean and lightweight framework to build front end stuff. I've been using this framework, CSS framework, from the starting. I don't like to get into the bare bones. Well, React is full front end framework. This is just a CSS framework, the Bulma, but React is fully fledged framework. Like, you can build all this functionality. It includes the HTML, CSS, and JavaScript, but it builds on top of that. Like, it's and for that you will have to refactor your uh, whole project, I guess, because you will have to create an REST API structure. Yeah, and in fact, that's also Vue, but in industry, React, there are more jobs for React than there are for Vue. Personally, I really liked Vue more than the React framework. By the way, if you want to implement this React, either React or Vue in your project, then you will have to refactor your project, I guess, because you will have to create the REST API structure. I don't know how it works in Django exactly. Like, if you do that, you won't have to, do provide the, I mean, the templates from the templates like this from the backend. Like, you won't have to return these templates. You will just have to return some data. Like, you will have to create a REST API. Do you know about REST API and stuff? Okay, well, so REST API is basically when, in your Django project, you will have to create certain endpoints. For suppose, let's say, if you run it on localhost, so suppose if your backend is running on localhost 3000, your Django project, and suppose you want to retrieve the products, then you pass products, then this request will go directly your backend. So that will be a specific endpoint for products, and let's say it is get all or something. So if you hit this endpoint on your backend, your REST API, which will be implemented in the Django itself, then it will do the usual stuff of uh, checking the database and retrieving all the products. And after that, you don't need to uh, render the results inside your template. You just have to return the results into a like a JSON format or something. And after that, and this request is basically being fired from the front end, which will be built using the React. So I won't be able to tell you everything in detail, but there are great tutorials on YouTube which will tell you how to build a full stack web application using React and Python as a backend, Python and Django framework. But I guess for now you can continue building this project using just the CT. Okay, yeah, sure. We'll see you. Sure, man. Anytime. All right, let's get back to the notebook. Where was I? We were reading this paragraph. In practice, since WD is a parameter that we choose, since WD is a parameter that we choose, we can just make it twice as big, so we don't even need okay, we can get rid of 2 as well. Great. To use weight decay in FastAI, just pass WD. Okay, we can directly pass the WD parameter and it will select the regularization. Okay, then let's do that. Let's get the model now. Model is equal to dot product with bias. We have n users and movies and 50 latent factors. Get the learner data model loss function is equal to MSE loss flag. So now we can do learn fit one cycle, not flat, fit one cycle. We're going to fit it for 5 epochs using the usual 5 raised to minus 3. It should be 5 raised to minus 3. And this time we are passing the weight decay parameter. Pass point. Okay, let's check the results now. What the loss function. What's the keyword argument? It should be lost func. Cool, we got 0.82 and previously we got 0.89, so this is better than the previous. Creating our own embedding model. Okay, So far we have used embedding without thinking about how it really works. Let's recreate dot product bias without using this class. We'll need a randomly initialized weight matrix for each of the embedding. First we create the class T inheriting the module. Self dot a is equal to torch ones, getting a tensor with 3 ones. After that we get the parameters from the model. Okay, it is empty. To tell model that we want to create a tensor as a parameter, we have to wrap it in the nn parameter. Okay, we have to do this. Now it will give us the parameters. Boom, and it also fires up this function requires create. Calling required red for us. It's only used as a marker to show what to include in the parameters. All PyTorch modules use nn parameters for any trainable parameters, which is why we haven't needed to explicitly use this wrapper up until now. Okay, the linear model directly applies nn parameter. Let's get the linear model as well then. It gets the linear model with, let me check the definition of linear model. We pass in features, out features, and bias. In features are 1, out features are 3. TA, what is inside A again? T dot A. What is A then? Wait. Okay, now this one. A. Damn. 2 dot T dot A dot weight as a parameter. Okay. We can create a tensor as a parameter with random initialization like so. Right, we have created a function create params, which will create the parameters automatically for us. Now we can create the dot product bias again. Okay, This time we are replacing the embedding with this function. So embedding is just that, creating, initializing the parameters, random parameters. This time we are creating parameters and we are passing a list containing n users and n factors. So it will create a matrix of this size, this many rows and this many columns. For bias as well, it will create the same function. Okay, we are only changing create params. Everything else remains same, I guess. And I think the key thing is this lines of code. This is what embedding means actually. Looking up the weights with this forward function. Does it mean forward means forward propagation of weights? It should mean that. Could be, I guess. Okay, now if we get the model of this function, it gives exactly the same results, right? So this is what embedding does exactly. Interpreting embeddings and biases. Our model is already useful in that it can provide us with movie recommendations for our users. But I don't see how this 0.82 is a good score. Like I'm sure it is better than the previous scores, but still, shouldn't we be improving it further? Interpreting embeddings and biases. A model is already useful. How the hell is it useful? It is giving us 0.82 error validation loss. That it can provide us with movie recommendation. Okay, so I guess this is good enough for movie. This recommendation systems, because there's no right or wrong answer, right? It's just a recommendation. But it is also interesting to see what parameters it has discovered. The easiest to interpret are the biases. Yeah, the movies with the lowest value in the bias factor. Right, let's get the movies with the lowest value, lowest bias values. Learn dot model dot movie bias. By the way, what is inside bias? Let's check what is inside this now. So it's a tensor, a rank 1 tensor. Is it a rank 1 or rank 0? Rank 1 tensor means I'm talking about deep learning stuff. I guess it is same for everything else maths, but what is the tensor? Okay, tensors and shape. The scalar is a rank 0 and a vector is a rank 1. The matrix is rank 2, I guess. Cool. So this is a rank 1 tensor. But when we squeeze it, I guess it converts into a rank 2 tensor, I guess. What did it do? Squeeze didn't seem to have done anything. So the dimensions remain exactly the same. Then why are we using the squeeze? What does it do? Anyway, let me try to find out. PyTorch squeeze. I hope it is from the PyTorch. It is from the PyTorch. What did it do? It converted this into this. We are passing x. And no. Okay, so let's say if I do unsqueeze, then I have to provide the dimension. Okay, let's leave it. I think we should run the model again, because the values might have changed while I was experimenting with this squeeze function. Let's get it inside movie bias, and we get the indexes movie bias dot arg sort. So what's the first 5 rows of the arg sort? We are sorting it, and we are sorting it in an ascending order. That means using a movie bias. So this first ones will be the movies which will have the least bias. We do DLS dot classes and we select the title. The destructuring for I in indexes. Okay, for I in indexes, get the title of this that index and source the titles. So these are the movies which contain the lowest bias. That means regardless of the kind of latent factors that this movies contains, these movies are the ones which tend to get, you know, reviewed as the worst, regardless of the latent factors, right? So when what's it saying that even when a user is very well matched to its latent factors, which is, as we will see in a moment, tend to represent things like level of action, age of movie, and so on, they still generally don't like it. These are the worst movies. Okay, in our case we don't have Home Alone because it is random. But now we have Robocop and Mortal Kombat. This seems like the worst movie. Let me try to Google this. Four 4.2. Cheap thrill. More laughable than. Okay, let's move on. So I see that we could have simply sorted the movies directly by their average rating, but looking at the learned bias tells us something much more interesting. It tells us not just whether a movie is of a kind that people tend not to enjoy, but that people tend not to like it watching it, even if it is a kind that they would otherwise enjoy. By the same token, here are the movies with the highest bias. Okay? Let's select it in the descending order to get the movies with the highest bias. This passing descending, it is equal to true. Okay. Shawshank is definitely is of that nature. I have watched Titanic and Shawshank. I've heard about Silence of the Lambs. I might have watched it. No, if I would have watched it, I should have remembered it. Psychological, I might have to watch this. Seems like a movie that I might be interested in. So, I've not watched LA Confidential. Should watch this one as well. And I'm guessing that this will be the movies which will be in the top list. So yeah, it is 8.2. So if we check the IMDb rating list, movies, top rated movies. This might, okay, the Shawshank is in the top list. Then I guess this Silence of the Lamb is also somewhere around here. Yeah, it is on the 23rd number. And Titanic might be somewhere around here as well. What about LA Confidential? It is on the 125th position. Cool. I might watch this movie next. So where was I? So for instance, even if you don't normally enjoy detective movies, which is not the case for me, I definitely enjoy detective movies. This is the genre that I like the most. You might enjoy Sherlock Holmes and all those series and movies are my favorite. You might enjoy LA Confidential. Let me bookmark it so that I remember to watch it. It is not quite so easy to interpret the embedding matrices. There are just too many factors for a human to look at, because we have 50 in total factors selected. But there is a technique that can pull out the most important underlying directions in such a matrix called principal component analysis, PCA. We will not be going into this in detail in this book because it is not particularly important for you to understand to be a deep learning practitioner, but if you are interested, then we suggest you check out the FastAI course. That's one. Computational linear algebra for coders. Okay, so I don't have to know about principal component analysis in detail to be a deep learning practitioner. Cool. That's hopeful to hear. And this is basically PCA. Ratings, group by title, rating not count, G's are short values. I'm not even going to try to, I'm gonna try to even, decode what all this stuff is doing. Let me just try to copy paste it and run it. Don't want to get into the details right. This is definitely not readable. So you can see that the model seems to have discovered a concept of classic versus pop culture movies or surveys. Perhaps it is critically acclaimed. It is represent. But we are what is 2-axis represents? Okay, it seems they are just selecting two of the factor latent factors, I guess. PCA 3. So they have selected 3 factors. Now they are not selecting F1, but they are only plotting factor 0 and factor 2. Cool. it seems to represent. We have ET over here, and these are the movies: Mission Impossible, Independence Day, Conspiracy Theory, Twister, Liar, Twister, Independent Saint, Conspiracy. So this seems like, what's the word I'm looking for? Conspiracy theory and political and action and all that. This group represents that, I guess. There's also Forrest Gump, Willy Wonka, Jerry Maguire, Toy Story, Full Monty, Schindler's List, Fargo, Dead Man Walking. So this too looks like crime thriller. Pulp Fiction. Okay, these are the science fiction movies. Star Wars, Terminator, Aliens, Empire Strikes Back. So these are, so negative means, does it mean that not so science fictiony? Because this bunch does contains a lot of science fiction movies, but it can also be okay. So yeah, this x-axis might be representing the yeah, it might be representing science fiction movies. Not so science fiction. I don't know. What is it representing? Classic versus pop culture. Okay, that might be the case. Classics. So this movies does look like classic movies. Yeah, so Star Wars, Pulp Fiction, these are the classic movies. Versus pop culture. I don't know what that means. Critically acclaimed. Okay, we don't need to worry about that, I guess. No matter how many models I train, I never stop getting moved and surprised by how this randomly initialized bunch of numbers trained with such simple mechanics managed to discover things about my data all by themselves. It almost seems like cheating that I can create code that does useful things without ever actually telling it out. Exactly, and that's what I said in the previous stream, that this particular model, I mean, it seems like magic. It's like beautiful, just a bunch of numbers discovering all these factors. We defined our model from scratch to teach you what is inside, but you can directly use the FastAI library to build it. Cool. So FastAI library does contain this collab learner that we can directly use, just like we used the CNN learner in the previous streams for computer vision tasks. Number of factors 50, and y range, this is for the sigmoid range. We are passing 0 to 5.5. Learn dot fit one cycle, 5 epochs, 5 e raised to 3, and weight decay is equal to 0.1. learn dot model. It's model embedding dot bias model with u weight, item weight, u user bias, and item bias, which is same as our custom model. We can use this to replicate any of the analysis we did in the previous section. Let's fire up this command as well. This giving us almost the same results. Cool. Interesting thing we can do with this learning embeddings is to take look at distance. Okay, what does it mean? Okay, the distance between two movies, I guess. On a two-dimensional map, we can calculate the distance between two coordinates using the formula of Pythagoras. Square root of x square plus y square. X and y, the distance is Pythagoras distance. This is also called the Manhattan distance, I guess. I think, but Manhattan distance, does it contain the square root? Let me Google it. Manhattan. Alright, so it doesn't contain the square root, but it does contain the absolute distance, absolute subtracts, absolute values of the subtraction. Cool. For a 550 dimensional embedding, we can do exactly the same thing, except that we can add up the squares of all the 50 coordinate distances. If there were two movies that were nearly identical, then their embedding vectors would also have to be nearly identical, because the users that would like them to be nearly exactly the same. There's a more general idea here. Movie similarity can be defined by the similarity of the users that like to like those movies. So if I like a particular movie, then a similar movie, I would also like that one, right? And that directly means that the distance between two movies embedding vectors can define that similarity. You can use this to find the most similar movie to The Silence of the Lamb. Similar movie, how can we get the similar movie? Similar movie to Silence of the Lamb. First we have to get the movie factors, okay? We're getting the movie factors. Cool. Now what are we doing with those factors? We get the classes according to the title. We get title and O2I. What is O2I? Copy the code first of all. I should mention classes. I should also mention data loaders, I guess. Let me try to run it. Gives us with classes contains a list of all the titles. The classes titles. We are selecting the classes titles. Now O2I. Does it do O2I? Select this one until there was you. One. Okay, it is giving us the index, I guess. This gives us the index. O2 index. O2I means O2 index. Object to index, I guess. So this returns the index. Of course, it returns the index. We have specified over here. Dummy. And we are passing that those index to movie factors. So we are retrieving the movie factors. First get all the movie factors, this movie factor, and we fire up this cosine similarity, which gives us the distances between all the factors and this factor, this particular factor. And finally we are just sorting it and getting the more distances. Descending is equal to true hence. Wait, but won't it return the indexing which are farther away? Or maybe this distances contains a parameter which specifies that suppose if the distance is lower, then that value is higher. For I guess that's what this distances might be returning. I think so. And if we run it, we should get farewell to arms. And what if we try to find a similar movie like Shawshank Redemption? This is definitely my favorite movie. Meet John Doe. Oh, cool. Search. What's the plot? A man needing money agrees to impersonate a non-existing person who said he would be committing suicide as it proceeds. It's a political movement. Okay, this is shown as the similar movie. I don't know why, but it is so. And what about Schindler's List? Let me find a similar movie as LA Confidential. Shanta with muscles. This is what a comedy movie or something. Amnesia. Right. And this seems like, wait, this seems like it has gotten 2.6 rating out of 10. How is this movie similar to LA Confidence? It's like the top rated movie. Maybe it is similar in the latent factor, but even the latent factors don't seem to correlate. Yes, it is not less accurate results. Let's move on. Now that we have successfully trained a model, let's see how to deal with the situation where we have no data for a user. How can we make recommendation to new user? The biggest challenge with using collaborative filtering models in practice is the bootstrapping problem. The most extreme version of this problem is when you have no user, and therefore no history to learn from. What products do you recommend to every first user? Well, but even if you are a well-established company with a long history of user transaction, you still have the question: what do you do when a user signs up? And indeed, what do you do when you add a new product to your portfolio? There's no magic solution to this problem, and really the solution that we suggest are just variation of user comments. As you could assign new user the mean of all the embedding vectors of your other user. May not be at all common. For instance, the average for science fiction may be high and the average for action may be low, but it is not that common to find people who like science fiction without action. But better would probably be to pick some particular user to represent average taste. How would I solve this problem? Bootstrapping a collaborative filter model. Let me think. Well, we can ask questions to the users, right? And indeed, some of the platforms try to get your, interest and all that to recommend you. Like, does Netflix do that? I think they do it, because in fact that is not a convenient user experience. We can also show the products which are highly biased, because this these items tend to be the ones which users like regardless of their latent factors. So that might be one case. Better still is to use a tabular model based on user metadata to construct it. Exactly, that's what I said. User metadata. When a user signs up, think about a question you could ask them that would help you to understand. That's all what I said or suggested. Then you can create a model where the dependent variable is a user's embedding vector. The independent variable of the results of the question that you ask them. along with the sign up data. We'll see in the next section how to create this kind of tabular model. You may have noticed that when you sign up for services such as Pandora and Atlas, they tend to ask you a few questions on genres you like. Yeah, they definitely do that. Spotify also does that. This is how they come up with your initial collaborative filtering recommendation. One thing to be careful of is that a small number of extremely enthusiastic users may end up effectively selecting the recommendation for a whole user base. This is a very common problem, for instance, in the movie recommendation system. People that watch anime tend to watch a whole lot of it and don't watch very much else and spend a lot of time putting their ratings on websites. As a result, anime tends to be heavily represented the result. Anime tends to be heavily overrepresented in a lot of best ever movie lists. In this particular case, it can be fairly obvious that you may have a problem of representation bias, but if the bias is occurring in the latent factors, then it may not be obvious at all. Definitely. So that might be the problem in the case where I suggested that we should show the users the most biased movies, the highly biased movies. So in that case, we might get recommendations such as this, where we get all the anime movie recommendations. And actually, I think that does happen because I think in Netflix it happened with me that once I watched just one anime, and then the Netflix recommendation system it it started giving me a whole lot of anime recommendations, and that much so that it started to filter out all the other recommendation system. Most of them and all the top were from anime only. So that might be the case, I guess. Such a problem can change the entire makeup of your user base and the behavior of your system. This is particularly true because of your positive feedback loops. A small number of users tend to set the direction of your recommendation, then they are naturally going to end up attracting more people like them to your system. Then that will of course amplify the original representation. That's definitely a problem. Positive feedback loop. This type of bias has a natural tendency to be amplified. I mean, it is bad for the system, but what if this kind of recommendation system is used in a very sensitive application? Then it might even be threatening and bad for the users as well. This might cause some great consequences. I mean, bad consequences. You may have seen examples of company executives expressing surprise at how their online platforms rapidly deteriorated in such a way that they expressed values at odds with the values of the founders. In the presence of this kind of positive feedback loops, it is easy to see how such a divergence can happen both quickly and in a way that is hidden until it is too late. In a self-reinforcing system like this, we should probably expect this kind of feedback loops to be the norm, not the exception. Therefore, you should assume that you will see them, plan for them, and identify upfront how you will deal with this issue. Try to think about all the ways in which feedback loops may be represented in your system and how you might be able to identify them in your data. Then this is coming back to our original advice about how to avoid disaster when rolling out any kind of machine learning system. It's all about ensuring that there are humans in the loop, that there is careful monitoring and a gradual and thoughtful rollout. A dot product model works quite well, and it is the basis of many successful real-world recommendation systems. This approach to collaborating filtering is known as probabilistic matrix factorization, PMF. Another approach which generally works similarly well given the same data is deep learning. So you can just use deep learning for collaborative filtering. To turn our architecture into deep learning model, the first step is to take the results of the embedding lookup. This is the last topic, okay. And concatenate those activations together. This usually gives us a matrix which we can then pass through linear layers and non-linearities in the user. Since we will be concatenating the embeddings rather than taking the dot product, the two embedding matrices can have different sizes, that is different number of latent factors. FastAI is a function that emphasizes that returns recommended sizes for embedding matrices or for a data based on heuristic that FastAI tend to work in practice. Okay, so if I get embedded size, we should pass the data loader class, data loaders. In this case, it's recommending us this size. Let's implement the class. Okay, we should get the class collab and then module definition, define init user size, item size, this should be y range. Y range is 0 to 5.5 and number of activation is equal to 100. Okay, yeah, 100. So what do we do? We get the user vectors of this size, user size, embedding of size, item size, and create a sequential, a linear layer, firstly linear layer followed by a ReLU and a linear layer. Neural network with two layers. First layer will